All right, welcome back. I'll give you an update here. If you're working along using our Gantt chart, if you're using whatever you want, that's fine. But if you were to use our Gantt chart, you'd see that by the end of the day, you should probably have your test cases done for all 3 exercises. But in reality, you could probably have the first 2 exercises done completely at this point because we've covered everything that you need to know for those 2 first exercises. The third exercise is a little bit more, and we do need to cover some other stuff before you can get a handle on it. But certainly you should at least have the like your program set up, maybe an outline of some sort. I need to open the file, I need to process the file, whatever. But that's what you should be working on by the end of the day. And of course, today is your lab 2, which covers loops and conditionals in Java. All right, so what we were covering last time, as of Friday last week, was lists. Right? We briefly talked about arrays, but then we realized, well, wait, arrays are a fixed size, right? And there's really no easy way of processing stuff. You have to do everything manually. Well, lists relieve you of having to do all that because they grow or shrink as you use them, as you add stuff to them or you remove stuff from them. They're ordered collections of similar elements. So if I create a list of integers, then that can only hold integers. If I create a list of doubles or strings, it can only hold doubles or strings, right? And the way that you do that is through this parameterization that we used here. Duplicates are allowed. What we're going to look at next is sets, and duplicates are not allowed there. But there are dozens of methods to help you process data. It allows you to add things. It allows you to insert things at a particular index, right? If you provide an index here, this will be inserted at index 3. 60 will be inserted there. You can remove things. You can retrieve things. Basically the CRUD, create, retrieve, update, and destroy of data structures. And then there are dozens of others that you just need to read the documentation about. If you want a sublist of some sort, then there's a function there to do that for you. What I want to do is I want to change this to a little bit different variety here. Let's go ahead and go with what's called a set instead. And instead of a set of integers, let's go ahead and bring in a set of strings. All right, so first of all, you need to, of course, import this. This is also going to be the java.util library. If I expand this up here, you'll see that everything that we've done so far is in the Java util. Util is short for utilities. All right, and it's no longer an array list. It's going to be a hash set. We might talk about hashing later on, but that's just one type of set, okay? All right, so once I've got my numbers, let's rename this as well. Let's rename this to names, right? I'm going to go ahead and add a couple of names to this thing. I can still use that same add method, right? Because that's how you get stuff into a list or a set. I'll go ahead and add my name here. Let's go ahead and add names.add Alex. All right. Let's go ahead and names.add Jane, and then finally John. Names.add John. John. There we go. Now let's go ahead and print this out. Remember that a set is different from a list in that it's an unordered collection. So system.out.println names. Now I added my name and then Alex, Jane, and John, right? But is that the order that they're stored in that set? Nope. Alex comes first, it's then Chris, then John, then Jane. That's not alphabetical order, right? Either, right? Because otherwise Jane would have come before John. It is an unordered collection. It's whatever ordering it decides is best, right? In fact, if I were to print this out multiple times after adding something, removing something, don't expect the same same ordering over and over again, right? Duplicates are not allowed here. You're probably covering, if you're taking 235 right now, you're probably covering sets, or you will be eventually. And sets are always going to be unordered collections of unique elements, right? Duplicates are not allowed in sets. If I try to add my name again, right? Let's go with Chris. There we go. And I try to print this out, it will have no effect, right? Because I'm already in that list. Right? So duplicates are not allowed. Duplicates are basically rejected. Right? That's how you can get stuff in. How can you retrieve stuff? So I want the first name. All right. So string first is equal to names.get. If this were a list, I could do something like this. Right? But can I get the first element out of a set? If it's unordered, is there such a thing as a first element, last element, second element? No. So I'm not able to get something using index-based retrieval methods here because there are no indices. So how do I do it instead? Instead, you use a for loop, right? For each loop. For string name in the collection names, right? We introduced this last time when we were looking at lists as a convenient way of iterating over a list without using an index variable. Now we can't use an index variable because it's not ordered, right? System.out.println name. Right? And I will probably get the same ordering as before, right? There it is, Alex, Chris, John, and Jane. But that's just internal to the set, how it stores things. That's how I can put stuff in. I can retrieve stuff. How do I take stuff out? Names.remove. Let's go ahead and remove me. Right? There we go. Come on, there we go. And then I will print out the list again, and you see that I am now removed. I can't remove the first element or the last element or the fifth element or anything like that, right? I have to actually remove the element, right? So now I'm gone out of that list. You can also replace stuff and do a bunch of other stuff, but let's just see what's in this API or in this list for us to the functions that we can use. You can remove all. You can get the size if you needed to know how many things are in there, right? We can convert it to an array if we wanted to. So there are not a lot of them here, but if you wanted to remove everything all at once, there's that clear method, right? So there are a couple of other, maybe a dozen or so functions that you can use to process data out of this. One other useful thing to do with sets and lists is to convert between them, right? So if I wanted to convert the set to a list, I can do so. I will have a list of strings, names, or names list, I'll say, list, names list, right, is equal to new array list. Now before, when I was using an array list, I just had empty empty brackets here, or empty parentheses. That created a new empty list. I don't want an empty list. I want to copy the names over to my names list. And so I can do that here. All it's going to do is go into that set, pull out each one, John, Jane, Alex, right? And then put them into this brand new list. And system.out.println names list. And we'll see that it's now a list instead of a set. Right? We're not going to see that from printing it out, but I can prove it by adding a duplicate. So names list dot add. Let's add Alex in there a second time. Right? And then we'll print it out once more, and you'll see that now we're allowed to have duplicates because now it's a set version of that, or it's a list version of that set. You can also convert, I should have spelled that correctly, a list back to a set, right? And it's the same syntax. So if I have a set of strings, right, no duplicates, right, is equal to new hash set, just like I did up above, but instead of providing nothing inside those parentheses, I would provide whatever collection I want to copy, names list. Right? And remember that names list, I added 2 versions of Alex there, or 2 instances of Alex. If I convert it to a set, then that duplicate is no longer there, right? Because it's been converted into a set. So lots of ways that you can process data really, really easily just using these built-in collection types. Right? So let's go over here. So as a review here, remember that sets, right? A set is an unordered collection of unique elements. Right? So in other words, no duplicates. Right? And here's our example code that we just wrote, and that's in the notes for you now. Okay. There we go. Remember that these notes are posted to GitHub. I posted the link to that in last week's retrospective, and you can follow that link there to get a copy of this, right, if you need to. There's one more type of collection that I want to introduce, and it's called maps. Those coming from a Python background will appreciate this because it's kind of like a dictionary, but it's actually a little bit more powerful than a dictionary. A map is a key value pair. A map is a key value pair collection, right? In other words, it stores elements using using a key that maps to a value, right? So for example, let me come over here. And one way that we could do this is we could map an NUID to a person's last name. So let me go ahead and create a map that does that. Now, with a key value pair, it's not just things that I'm storing, it's the key and the value that I need to store. So inside this Langle Wrangle, I'm going to actually provide two parameters. I'm going to want to say that this is NUID to last name, right? I'm going to map my NUID to my last name. And so an NUID is an integer, right? That will map to my last name, which is a string, okay? And I'll just call this NUID to last name. Right? New hash map, kind of similar to a hash set. Don't worry about the details. We'll talk about those maybe much later on, what hashing is maybe, or that's a CS3 thing, right? And I do need to import these. Remember that all this stuff is going to be in the utils library, okay? Once I've got my map, I can't just put stuff in because like adding it would append it, or with a set, it would throw it into the collection somehow. I actually need the key and the value together. So NUID to last name. Instead of adding, I put it. Right? I'm going to put my NUID, which is 0602. Right? No security issues there. And then there's my last name. Okay. I can similarly do a couple of other more dummy pieces of data here. 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 1, 2, 1, 2, 1, 2, right? And let me go ahead and print this out to show you that duplicates are allowed as far as values go. So system.out.println NUID to last name. Okay, I don't want typing, so let's go ahead and copy, paste. There we go. All right. So my first observation here is it is the order that I put them in, but there's no guarantee on that, right? There's the first NUID I put in, there's the second, there's the third, but don't read anything into that. But you can see here that I've got 3 versions of my last name there. In other words, values may contain duplicates, but ... Can we have duplicate key values? What I mean by that is, let's go ahead and try to do this where I'm going to map my NUID to somebody else's name, right? Jones or something, right? There. Now what's happened here is that I have lost the original value, right? 35140602, that can only ever map to one thing. So the takeaway from this is that values can contain duplicates, but keys cannot, right? Keys are unique, right? Okay. All right, so I can put whatever I want in. How do I retrieve stuff? Retrieval, right? You need the key, right? Just like you need a key to open a locked door, you need a key to find whatever you're looking for in the hash map. So let me go ahead and pull out, foo is equal to NUID, oops, just go ahead and copy this, NUID.get, right? Just like we did with a list, I can get, but it's not index-based anymore. What I need to do is I need to provide a key, 35140602. Right? And remember that I changed it so that it's no longer pointing to Burke. At first it was pointing to Burke, but now it's pointing to Jones. So when I print out foo system.out.println, it's going to end up printing out Jones, right? Because that's the value associated with that key over here, right? It's really, really powerful. If you think about arrays or lists, they're kind of like maps, but they're really, really restricted. You can only ever use integers for your keys. You can use whatever you want for your values, but you can only use integers, and they have to be 0 through n-1. They have to be ordered. I don't have to do any ordering here. I can use anything that I want with a map. I could change this around so that it's a string mapping to an integer. I could map an integer to another integer. Right? I can map whatever I want to whatever I want. So it's really, really powerful in that regard. What happens if you try to find something that doesn't exist? Let's go with get 5555555. Right? Is there a person with that NUID that I put into that list or into that map? No. Right? So what ends up coming out is null. And those coming from a Python background will recognize this in a different term, none with a capital N. Those coming from a C background will recognize null immediately, but remember, in this case, it's all lowercase. In C, it would have been all uppercase. So it's the same concept. It's pointing to nothing, right? Or it's referring to nothing. That's how you can get things out. How can you iterate over a map, right? Well, there are a couple of ways of doing it. I'm going to show you the easiest way of doing it. You can iterate over the keys, right? So for the keys in this case are integers, right? Key in the collection, NUID to last name. Now, this is how we did it with a list or a set. But this is a little bit different because this map is actually a pair, right? It's a key mapping over to a value. So I can't just map over, or at least the way I'm doing it right now, I can't just iterate over the pairs. Instead, what I have to do is I have to iterate over the key set, right? And note here that it is a set. It is unordered, right? There is no order. That's just the order that I put it in, that's the order that it happens to come out in. But that's just a coincidence, right? Don't read anything into that ordering on the keys. Once I've got the key, I can put it into the lock and open the door, right? I can actually get the value. So string value is equal to NUID to last name dot get, as I did before with the key. Now I've got both of those things. I've got the key and the value, and I'll just go ahead and print them out here. System.out.println key plus, and then the string here maps to, and then another plus for concatenation value. And I'll get kind of like the behavior of just printing it out, but I could actually process the data as I go along if I need to, right? So you can put stuff in. You can also remove stuff. You can retrieve stuff. How do you remove stuff? I forget. I think it's just remove, right? Dot remove. Yep. Just remove it by the key. So if I remove 35140602, right? Now Jones will be gone entirely here. Let me copy this so I don't have to retype it all out. There we go. So only removable. Things are only removable by their key. They're only retrievable by their key, right? You can also iterate over a maps values, right? So remember in this case the values are strings, right? Because they're names. Name in the okay, let's go with string name in the collection NUID to name. There we go. All right. And instead of the key set, I need the values, right? So you can get all the keys, you can get all the values. Once you've got the keys, you could get the values, whatever you're trying to do, for that particular use case. System.out.println name. And here I've lost all the keys because it's not invertible. I can't go from a value, say Burke, mapping back to the keys because multiple keys can map to the same value, right? So it's not invertible. You'll also learn that in 235 in discrete math. What makes a function invertible? It has to be one-to-one and onto, or surjective and injective, right? And there are all the values that are left in there, okay? All right, so there is a map, right? We might come back and do an exercise using a map. I don't know if they still do it in one of the CS ones, but I steal one of their exercises, and we show how much easier it is to do with using a map. Okay. All right, so maps. Any questions so far? No? Okay. Then let's go ahead and talk about strings, and we'll come back and do some exercises later on. So those coming from a Python background will immediately know, I can do strings. All I need to do is concatenation. I can do whatever I want with strings, and it's really, really easy. Those coming from a C background, however, will remember how difficult it is. You have to make sure, if you're doing anything with strings, you have to make sure that there's enough memory to hold whatever you're trying to represent. You have to make sure that there's a null terminating character at the end. Right? You have to do all this bookkeeping for yourself. But in Java, none of that headache. Right? Java has a string class or type. There's no memory management. There's no null terminating character, and you can do basic concatenation with anything that you want using the plus operator, right? However, one thing that you need to understand is in Java, strings are immutable. That is, once they're created, they cannot be changed. You can always create a new string with different content if you need to, but it cannot be changed, right? And then there are lots of nifty little methods that you can use in the string library. All you have to do is RTM. Remember that RTM stands for read the manual, right? Or read the documentation. So let's come over here and start playing around with some strings. I'll go ahead and do my name again, string name, my first name in this case. And oops, I've left the first letter on lowercase here, right? I want to change that to uppercase. Now in C, you could definitely do this. In Python, I believe you can do this. I forget if strings are immutable or not in Python. I'm going to have to figure that out for the next class here. But you could also always reassign this to a capital C, right? You can't do that in Java. Why? Because it's not an array, right? It is an actual class. So what you could do, though, is you could change it to all caps, right? Let me print this out first, system.out.println name, right? And then name dot to uppercase, right? There is a function to convert them. That'll actually convert all of them to uppercase. I really only want to convert the first letter to uppercase, but let's see how this works. And let me go ahead and try to print this out. Right? Remember what I said. Now, what would you expect here? I would expect Chris all lowercase and then Chris all uppercase because that's what I intend for it to happen, but it doesn't work. Why? Let's go back to this statement right here. Strings are immutable. Once you've created them, you cannot change them. So what the hell is the use of a to uppercase if it's not going to change anything? What it does is it returns a new string, right? And what I have to do is I have to capture that value, right? There we go. Now the old string is still, lowercase, but the new string called upper, that has been converted all to uppercase. So if you're going to call any of these functions on the string class, right? Say name dot. There are dozens and dozens of functions here that you can call. Most of them will be producing a new string that you have to capture into a separate variable. Because once you've created a string called name with lowercase chris, right? Then that's it. You can never change that, right? Now you could reassign that value. Name is now equal to properly my capital C Chris, right? But what that's doing is internally, it's creating a brand new string. This old string over here still exists. It's actually probably going to be cleaned up by the memory manager and the garbage collector. But ultimately, it's creating a brand new string, right? This creates a brand new string, right? Because strings are immutable. What other things do we have there? Dozens of nice methods. Right? For example, name dot, let me go ahead and restore this to my full name, Christopher, right? Name dot substring, right? Or what I want is a substring. There we go. Right? And I don't want my full name. I don't know, maybe my last name. There we go. I want this part of the substring, right? Starting over there. So what you can do is you can have a substring starting at a particular index. I don't know what that index is. Let's just go ahead and guess what it is. Maybe it starts at 10, right? And remember that that's going to return a brand new string because we can't change name once we've set it, right? So string last name is equal to. Let's see if I guessed correctly there. I don't know where. If you want to count over and tell me how many, what index does the capital B appear at here, right? We'll find out here in a second, right? There we go. Oh, so close. I just need to go up 2 more. There we go. And I can get a substring. I can just get the last part of it. There's my last name instead. Right? What if you want a substring that begins at the beginning but only goes, like say, for example, I just want Chris out of that instead. String first name is equal to name dot substring. There are 2 versions of this. Right? There's one with the beginning index, and then there's one with a beginning index and an end index. All right, I want to start that beginning index at 0, and I only want to go up to CHRIS. So that would be 0, 1, 2, 3, 4. So, question mark, will this work? Let's find out. All right, first name, Let's print that out. Do I get CHRIS out of that now? No, I don't. I'm missing the S. Why? Again, what should you be doing? You should be RTMing, reading the manual. How does this actually work? If I hover over this, it'll tell me how this works. It returns a string that is a subset of the string. The substring begins at the specified begin index and extends to the character at the end index -1. So 4 minus 1 would be 3, so 0, 1, 2, 3. That's why I'm getting stopping at the I. It's always used, that pattern is throughout many, you'll see that pattern in Python too, where the first index is inclusive, it includes it, and then the last index is exclusive, it does not include it. It's always -1. And that's because of the way that indexing works. You always start at 0. So let me fix this and go ahead and put 5 there. Now that's really nice because the length of the string that results is always going to be the second argument minus the first argument. So in 5 minus 0, then it will get me a string of length 5, CHRIS. Right? And there we've got it. Okay. If you need to know how big a string is, you can do it using system.out.println. Let's say first name dot length. Right? That will tell me how many characters are in there. How many characters are there in CHRIS? 5. Right? Remember, C, folks. There is no null terminating character. Even str length len in C would not count the null terminating character. Right? What else? What else is out there? What's interesting? String comparisons. Comparing strings. Actually, before we do that, let's go ahead and do you want to see any more? Name dot. Right? You can get a particular character at a particular index. You can get characters as a stream. In other words, you could iterate over them. Does it contain a character sequence? Does it end with? And I'm pretty sure that is there a begins with or starts with. You can get them as a byte sequence instead. You can get the first index of a particular character, the first index of a substring. Right? There are dozens of these things that will be. You can replace values there. You can strip out white space, you can convert it to uppercase, convert it to lowercase. You can do like dozens and dozens of different things, right? So you'll just have to RTM, read the manual, right? Usually if you need to do something with a string, there's probably a function built in to the string library to do it for you. But how do we go about comparing strings? Let's go with string A is equal to apple, right? And string B is equal to banana, right? Now, I could use if they're equal, right? If A is equal to B. And this would work in Python. Would this work in C? What are you comparing in C if you're using equals equals? You're comparing memory addresses. And the same is true in Java. System.out.println equal. Right? Now, of course, apple is not equal to banana, so it's not going to print anything. Right? Let me go ahead and say not equals. Else. System.out.println not equal. And we'll see that they're indeed not equal, right? And I think we covered this last time, but here it's actually going to say that they are equal, but that's just Java doing some trickery there. It's saying you created two strings of the same contents. I'm not going to create two things in memory that are the same contents. I'm going to make A and B point to the same string or refer to the same string and refuse to create a new one. Here's how I can force it to create a new one, right? Okay, that is going to be definitely something different in memory. And now it's going to actually output that they're not equal because they're not. A is stored over there in memory address 12345. B is stored in memory address XYZ2, right, or ABC2, right? They are not the same memory address, and that's why it outputs not equal. Equals equals is not how you compare strings. Instead, to compare strings, you use dot equals, right? And that will say that the contents are now equal. Right? There we go. Now they are equal because I'm using two apples there, apples and oranges. Right? All right, that's for equality. What if I want to know, does apple come before apple or banana, right? Let's go ahead and reset these to apple and banana. Remember, that's going to create new strings. Here's a better way of doing it. If A dot compare to, right, B. Now that compare to function is like a comparator in C. or a I don't know if they call them comparators in Python, but it's the same basic idea. It's going to return something negative if they're in order. A comes before B. It's going to return something positive if they're out of order, or it's going to return 0 if they're equal. And I can make a comparison there, right? Okay. If it's negative, that means that system.out.println A comes before, and then B, right? Because it's returning something negative, okay? Otherwise, if it's the other way around, I can copy all of this, right? Go else if it is positive, then which one comes first? B comes before A. Else, what is the only other possibility here? It's not going to return something positive, not something negative. It's going to return 0, in which case they are equal, right? So A equals B. There we go. So in this case, which one comes first? Does apple come before banana, or banana come before apple? Right? Hopefully we know our ABCs. Right? And which one comes first? Apple comes before banana. Right? If I swap them out, banana and apple, it would say that apple comes before banana still. If I said that I was comparing apples to apples, right, they would say that they are equal. Right? What happens if you pluralize one of them, though? Which one of those comes first? The singular or the plural? Singular, right? Why? Because it's shorter, right? So apple comes before apples. Right? What if you did this, though? Which one of those comes first? It's not case sensitive. I mean, it is case sensitive the way that we're using it right now. But which one of them, if you were to look in the dictionary, of course, they're right next to each other, right? There is no ordering there. But in this case, capital A apple comes before lowercase a apple. Why? Because of that thing called the ASCII text table, right? Let's go look it up. New ASCIItable.com, right? Let's see. So it predates modern computers because it was based on typewriters, right? And what do we see here? Capital A through capital Z, all of those come before the lowercase versions over here, right? It's alphabetical, but it's the capitals come before, right? For example, a capital A has a value of 65, lowercase a has a value of 97. So capital Z here, that would actually come before lowercase a. So if I did something like this, banana, right? Which one of those comes first? Well, apple comes first according to the dictionary, but according to the ASCII text table, which all code is based on, the capital B would come before the lowercase a. So it's not alphabetical. This is what's called lexicographical. Ordering is based on the ASCII table, which is lexicographic ordering. Right? It's not alphabetic. If you want alphabetic, you would say compare to ignores case. And in this case, it's going to say that apple comes before banana, right? If you actually need to do something like that, but I'm not going to do that. All right, so it also works for numbers. 123 versus 9. If you were to treat these as integers, which one of them would come first? A smaller one, 9. But these are not integers, right? Which one of these comes first according to the ASCII text table? Well, I see a 1 and I see a 9. It doesn't matter what else is over here. I'm looking at the first character first, right? And 1 comes before 9. Right? So what order is it going to say? It's going to say 123 comes before 9, right? That's because it's lexicographic. So you have to be careful when you are comparing strings, right? You have to do it properly, and then you have to understand that it's lexicographic according to the ASCII text table and not alphabetic, right? Any questions on strings? Otherwise, just RTM. There's lots of nice functions there for you to use, right? It makes string processing much easier than, say, C. And we'll talk about processing data here after we get to files. Right? All right. Eventually, you're going to want to write your own functions, right? Because if you just put everything into main, like I've been doing up till now, it's really disorganized, right? You do not want what it's called a God method, or we'll talk about God classes later on, where you put everything into one big method. It does everything, it sees everything, it is everything. It's a God method. You don't want to do that. Instead, what you want to do is you want to write your own functions, right? Also called methods. Now, I'm putting methods into quotes here, right? Methods, functions, same thing. There is a technical difference. In object-oriented programming, we call them methods because they belong to a class. Otherwise, if it's not an object-oriented programming method language like, say, C or Python, we would call them functions, right? It doesn't matter. I'm going to use them interchangeably, right? Methods are just functions inside of a class. So let me go ahead and create my first function here, right? I want to compute the distance from point A to point B using Euclidean distance. Do we know how to do that? Like if I have x1, let's say x1, y1, and I want to know what the difference is, or what the distance is to x2, y2, right? What is the formula that I would use for that? It's a sum of square of differences, right? So x1 minus x2, right? Times x1 minus x2. I just repeated myself. I could have used math.pow. Why? That's kind of a sledgehammer when this one will work just as fine. Plus the same stuff but all y's, right? y1 and y2, y1 and y2, right? So there's the sum of squares, but then what do I need to do with it? Math.square root of it. Right? There we go. And there's the result, okay? Now, if I were to do this in main, right, and I have values, I don't know, int, or let's go with doubles, x1, we'll start at the origin here. Double x, y1 is equal to 0. And let's go up to, I don't know, 10, 10. Double x2 is 10. Double y2 is equal to 10, right? And I can go ahead and, compute that and print it out. System.out.println, whatever value I need to store that value, of course. Double distance is equal to that. What would the distance be? Does anybody know? Can anybody do that calculation in their head? Probably not, right? But it would be 100 squared, or 10 squared times 2 because there are 2 of them, so 200. What's the square root of 200? Apparently it's 14.14 or something, right? You can verify that using your calculators if you want. But that's actually kind of complex. I mean, it's not that complex, but I don't want to sit there and stare at that and every single time I need to use it, and I need to use it there, and I need to use it there, and I need to use it there, because I'm going to be computing this over and over again, right? I don't want to repeat myself, first of all, but also I don't want to sit here and stare and what is that actually doing? Oh, that's a Euclidean distance formula, right? Put that into a function with that proper name. It's going to be a public function. In other words, anybody can use it, anybody can see it. It's going to return a double value because it's going to be computing a Euclidean distance. And I'm also going to make it static. I'll talk about that in a moment. But for now, all of our functions are just going to be static. And I'm going to have to give this a name, right? Could I call this distance? Yes, I could call this distance. But is that a good name? There are lots of different types of distances. There's Manhattan distance. Is this your? This actually might be your part of your assignment. There's Manhattan distance. There's Euclidean distance. There's the L2 norm. There's the L3 norm. There's the N norm, depending on what dimension you're looking at. Right? There are lots of different notions of distance. Give it a better name. Right? Euclidean distance. That's a little bit of improvement, right? But now, think about how your naming convention should go in any language. Variables are things. In English, we call those nouns, right? But functions are not nouns. They do things. In English, what's that called? A verb, right? So in other words, your function should be verbs. This could be calculate Euclidean distance. It could be I don't know of anything else. There's an old adage. There are only two difficult things in computer science. One of them is cache invalidation, and the other is naming things. So usually people just call it get. Get the Euclidean distance, right? And that is a verb now, right? We've verbized whatever that noun was. In English, those are called gerunds, right? All right, so what I'm going to do is I'm going to pass in 4 parameters here. Double x1, double y1, double x2, double y2. So look at the syntax so far. Let's zoom out here. I have a public static double. I need to name it, give it a sensible name. And note here that I've used lower camel casing, just like my the same convention as my variables. Then you have a parameter list here, right? And you have to name the parameters x1, x2, y1, y2. The order matters, of course. And then finally, a difference that you have from Python is that you actually have to say what types these are, just like we've been saying down here, okay? Now, that x1 is not the same thing as this x1. They are in different scopes. This x1 belongs to this function right here, get Euclidean distance. This x1 belongs to the main. So I can't make changes to it. If I tried to make changes to it, it would not be reflected. x1 is equal to 10 now, right? That does not change this x1 down here. It's still 0, right? Because they are different x1s, all right? But I can take this code and I can put it up here. And now I have a nice, sensible name for this function, right? Now, one thing I need to do is I need to return a value. If I don't have a return statement here, it is a compiler error. It's going to say, wait, you have a non-void function, a function that returns something, but you don't have a return statement. Now, those of you coming from a Python background, this is a big improvement, right? If you were to write a function in Python and that returns a value, returns a result, and you forgot the return statement, Python would be perfectly okay with that. What would it end up returning? Do you know? None, right? N-O-N-E with a capital N. And then you're sit there wondering, why the hell is this not computing? And it's because you forgot your return statement somewhere. And if we forget our return statement here, the compiler is going to actually help us out and say, you need to actually return that value, distance, okay? Now I can go ahead and call that function down here. Distance is equal to, however, this function is part of the demo class. So just like the math class has this function called square root, what we need to do is we need to use the name of the class where the function belongs, or it lives, right, as declared, and then we can use a dot, and then we can pass in our parameters here. Your IDE will do a lot for you to autocomplete everything, right? All right, and let's run this. Great, it still works. But we have a sensible function, sensible descriptive function name that hides the detail of what this math is doing that I don't want to have to think about. Now, we're still not done here. First of all, those from a C background, there are no function prototypes. You just declare it and use it. Now, those coming from a Python background, does it matter where you put the function? In Java, no. You can put it above, and then you can use it below. You can put it below and use it above, right? Usually, though, you put them up at the top. Your main should probably be the last thing that you have in your class, if you have one, right? Now, the other missing part here is documentation. Every single non-trivial function that you write and turn in is going to be graded for its documentation. A small amount of points, but still points nevertheless, right? Now, do you see the magic that just happened there? I began it with a doc-style comment, right? That is /**, just hit enter. And it automatically completes a lot of it for you, right? That's also in blue. It gave me this nice line of vertical stars, et cetera, et cetera. All I have to do is write some documentation, keep it simple, of what this does, right? Computes the Euclidean distance between the two given points. And here what you can do is you can mark it up. Code x1, comma y1. There we go, code. All right, and another code, x2, comma y2. Right. And by putting it in, these are HTML tags if you're not familiar with that. By putting those tags in there, you can look at your own documentation here and you can see what happened here. Right? They've been marked up in a Courier type font, well, monotype font, and so you know what it offsets it a little bit. Right? You can also do other sophisticated things. For more information, see Wikipedia, right? Or Wikipedia, whatever it's called. href is equal to here. Right? Now, if you're familiar with HTML, you'll see that this is me building a link. Right? Let me go ahead and create a link to Wikipedia on this. Euclidean distance Wikipedia. There we go. And there's a nice Wikipedia article with everything that you would ever want to know about Euclidean distance. And I'm going to go ahead and put that right here. Okay? Now, when I look at the documentation that this generates, you see what's happened now? There's a nice little link there. If you click that link, let's see what it does. It opens it up, right? I already had it open, but it opens it up in a new tab here, right? So you can get really, really sophisticated with your doc-style comments. I would recommend, we're not expecting, HTML beauty in all of your comments. All we're expecting is that you tell us what the function does, right? Euclidean, we're not even going to grade you on spelling, right? If I misspelled that. It just doesn't know what Euclidean is. Right? All right, any questions? If this were in a different class, by the way, you can go ahead and create another class. New class. I don't know, call it utils, right? Like we did with flood utils, right? in your first assignment. What you can do is you can move this off, copy, get rid of it, paste it over here. This could be like in a distance utils or something like that, right? And I just auto reformatted it, right? Now it's no longer in this class. It doesn't. Demo no longer has that. Utils does though, right? So you can offload stuff into other classes, reorganize your code so that that things are in sensible classes and sensible packages. Everything should have documentation. Okay. All right. Let's see. So put that in the notes, and remember that all non-trivial methods require full doc style comments. Right. For your first assignment, if you choose to write, I think we've done it for you, but if we haven't, then we would have put a to-do there. You need to write the documentation for whatever functions we assign you. Also, keep in mind all of your first assignment classes require author documentation. Right? So again, doc style comments, / vertical line of stars, all line nicely and make it look nice. If you can't make it look nice, right, because you've got terrible typing skills, you can always go Shift Command F and it'll reformat everything for you. Right? There's how I wrote it. If you go Command Shift F, that's acceptable. If I just go Command Shift F, then it will. I thought it did. There we go. There. Command Shift F, and all it's doing is breaking it up into shorter lines. Don't have long lines. If you have bad indentation, right, it'll save you from yourself as well. Right? It fixes the indentation. Again, that's Shift Command F on a Mac. It's probably Shift Control F on Windows machines. Okay, we'll pick it up there on Friday. Good luck on your lab.